Hey everyone, and welcome to Big Ideas 1.2, where we're talking about transformations of linear and absolute value functions. And I'm really going to spend more time on the absolute value functions than the linear. I think it's kind of hard to see transformations as well with linear functions because of them just being just a straight line. The absolute value functions we should know at this point are the V-shaped functions, and so we can maybe see those transformations a little bit better with the V-shaped functions. There are four types of transformations. We talked about those on the last lesson as well. Here they are as translations, reflections, stretching, and shrinking. So that's the four different types of transformations we're going to be dealing with. All right, let's first do a little cartoon of the day. This is a Far Side cartoon. Back in the Old West, never park your horse in a bad part of town. You can see the legs of the horse are gone, like the tires of a car. You know, somebody came and stole somebody's tires away. Apparently, he used to steal horses' legs away. I don't know how that would work out, but it just makes a funny cartoon. All right, so as we go into our core concept, this is on page 9, where we're looking at the translations. And we talked about last time that translations are just going to be moving the position, changing the position of our graph. And in this core concept, it does give us the linears. These are all just straight lines. And like I said, it's kind of harder to see those. So if you can kind of pay attention to my V-shaped ones over here, they'll be a little bit better, I believe. But basically what you want to write down underneath this core concept on page 9 is you want to write this down here. This horizontal equals inputs equals x value. So because what we notice that's different on this one that we didn't see on the last one is now we have a horizontal and a vertical translation. And we did see that a little bit last time, where we see the horizontal translation is going left or right, the vertical translation is going up or down. But we need to realize that the horizontal is always going to be talking about the inputs. It's where the x value is, and so that's why I'm putting that down there, and it's just going to happen to x because we're going to be having to write new functions. They're going to tell us do a horizontal translation of this. We're going to do that just to the x only, where the x is in the function. So as you can see, that's why this is here. You may want to highlight this part right here. The graph is right here, x minus h. See, that's where it's in where the x is. That's where it is. It's in where x is. Whereas the vertical translation, the k, the plus k, is out here past the function. So you have your function, whatever that is. It could be a linear function or an absolute value function, and you're just going to add a number or subtract a number at the back. And so that's why we want to say vertical equals the outputs is the y value. So that would be the y value, which the whole thing means you're going to do it to the whole thing. So whatever you're going to do, in this case we're going to be adding or subtracting our numbers. So you want to put this down, but you can put down maybe between these here that this is add or subtract. We're going to either add or subtract to either just the x value only or to the whole entire thing, which means putting it on the outside of the function and doing it that way. Okay, so I think maybe seeing these here, I'll pull these over. Here's the absolute value functions. Our black one is the parent function, just the normal one. And then this red one here is where you're going to be putting, moving it to the right. But notice how it is. It's x minus 2. It's always the opposite of what it appears to be. So it's h actually is positive 2 on this one because you're going to go right 2 units, positive 2. But it looks like negative 2 in here. Essentially, what that number is what would make this 0, what would you need to plug in for x that would make that a 0? It would be a positive 2. And that's why it's positive 2 over here. This one you can see moved left 3 units, but it says x plus 3. So we added or subtracted a number inside just to the x only when we're doing a horizontal translation, moving it left or right. This one here, you can kind of see this a little bit better. You're moving it up or down. Our black one again is our parent function right there at 0, 0. But this one, red one, moves up, and you can see where it's moving up is outside the function. So here's your function, right? The absolute value of x. This is adding a number to the outside of the function to the back. And when we subtract the number from there, it just goes down. So this one, it is what it does. So if it says plus 2, it's going to go up 2. If it says minus 2, it's going to go down 2. Okay, let's take a look at page 11 in your notes. It says we're going to write a function g whose graph represents the indicated transformation of the graph of f. And it says you can use a graphing calculator to check your answer, which we're going to do that for the absolute value ones. I'm not going to, or just some of them, not all of them, but a few of them we'll check our answer on. And I'll have you actually graph those on your paper. But as we look at this, it tells you the f of x function first. This is our f of x function. Then it gives us a given transformation. This one, first one says we're going to translate this absolute value function. You can see absolute value symbols. Translate it 2 units to the left. So first of all, what you want to recognize is that it's got to go left. Left would be horizontal. So we got to go back to thinking to our horizontal, way of thinking. So it's going to be doing it just to x only. We're going to be either adding or subtracting a number just to x only on this one. So first thing we want to see is what that's going to be. H is going to be -2. So if it's going to be going left, we know it's got to be a negative direction. So our H number would be -2. So there's an H number and a K number. The H number would be for left or right, kind of standing for horizontal. And then K would be for the vertical, going up or down. So when we want to go up or down, we'll talk about K. And we'll get used to seeing H is always left or right, K is always up or down. So to translate 2 units to the left would be H equals -2. We're now going to do that inside. So this has got to be done in with X. So got to go inside here with the X. So it's going to be the function, and then like you have your f of x right here. So X is inside here. It's going to be x minus -2. So it's got to be always x minus h. We saw that back over here as well. We saw it right here as well. We saw the x minus h. That's why I had you highlight that. X minus whatever the h is. Our h on this one is -2. So that's what we need to do. So that can double negative, we can make that into a positive. So now it's just going to be x plus 2. So that tells us what we need to substitute in for this x. We need to replace the x in the function with an x plus 2. So now it'll look like this. Our g of x, we're going to change f of x to g of x, because that's what it said to name it as. All right, a function g. And so we have our 1/3. Instead of x, though, we're going to now put x plus 2 inside there. And then we just want to distribute that 1/3 into that to get our final answer. So 1/3 times x, 1/3 times 2 is 2/3, so it's the absolute value of 1/3 x plus 2/3. That's our final answer for this one. Number 2, you can see it says we're going to translate. Now this is another absolute value function. We're going to translate 6 units down. So down would be vertical. We're going to talk about a k number on this one. So down is in the negative direction. So k is a -6. So you got to be careful about these. You need to know the direction that it's going for the h or k number. So left is negative, right would be positive for this h. Down is negative and up is positive. So you need to know those numbers. But as you put in this number, notice it goes in where it's x minus that and actually becomes a plus 2. So it kind of changes signs as you plug it into this. This one's just going to go right behind the function. So remember this one, we're going to be subtracting this 6 from our entire function, like right where here. Our k is going to go past the function. It's going to do it to the entire thing, the whole thing. And so we're going to put this as f of x, and then we're going to put minus 6, or plus a -6. It's the same thing as saying minus 6. So that's what we're going to do here. So we have our function. So this would be our function, and I'm just changing it, the f of x to a g, to now name this as a g function. But I didn't do anything different yet. I just copied this down, and now I'm going to put this whole thing in parentheses, the entire function, and then we're going to subtract 6 from this entire function. So I'm going to put minus 6 at the end. So the only thing that's going to be able to happen here is that we're going to be able to put the minus 6 together with this minus 1. That's all that's going to be able to happen. Combine like terms. Those two like terms combine to a 7, or a -7. So our final answer then, these two just combine to this -7. So it still has the negative sign in front, still has x plus 9 inside the absolute value signs. The only difference now is there's a -7 there. Okay, let's take a look at this one. This is a linear function, 7 units down. So again, it's going to go down. That means k is -7. So that means it's going to be done to the whole thing. So f of x and then minus 7. I put plus on that one, but we can just change that to a minus to make it a little easier and simpler. So the function minus 7. We're going to subtract 7 from the entire function. This is the entire function, so let's write it out. Again, I'm going to change the f to a g and make that pronounced there on this one. Here's our function. We're going to we're going to subtract 7 from this entire function. I'm going to put that function in parentheses and then just put minus 7 in the back. So now the only thing we're going to be able to do is just right there combine these two like terms. 2 minus 7 can combine and it becomes negative 5. So that's what we end up seeing right there. So now we have a negative 2x, that's the same, but this 2 minus 7 becomes minus 5, and now there's our function. So before we leave, I want to go back to number 2. I want to show us the graph on this one, what the graph would look like. So let's take a look at this graph. I'm going to make it a little bigger for us. So here's our parent function for the absolute value. It's way up here. Here's our f of x function here. This is the one in red is the f of x function, and the one in blue is our g of x function. And so you can see the translation from this. For one, you can see how it translated from the original. So from the original, it reflected over the x-axis, because now it's opening down. It also moves to the left 9 units. That's what this is doing right here. The plus 9 in there is making this move to the left 9 units, because it's always the opposite of what you see. It's also going to go down 1 unit, so it puts it down right there. So one thing we can identify is the h and the k numbers. This number would be our h number right here. It would be negative 9. K number would be negative 1. That is our vertex that sits right there. So you go ahead and draw a little coordinate plane. You can just do a little coordinate plane. You go and do a sketch of this original function. This is just the parent function. The absolute value of x is what that is. So this would be just the let's just say y on this one, just so it doesn't get confusing. This is just the absolute value of x, which would be this function. And then for this one, the red one, that is our f of x function. So this is f of x here. Has a vertex right there. So the vertex is the h comma k point, which in this case would be negative 9, negative 1. And that's the h comma k point. It's flipped over because it's reflected. It's got the negative in front as well. And then this blue one is the g of x function now down here. So this is our g of x, which now you can see on this one, it's got a negative 9, negative 7. So this, our vertex point right here, is now negative 9 and negative 7. And it's flipped down as well because it still has the negative. Now it's still the same shape as the parent function. It doesn't change the shape. Because notice in front of this, in front of the x inside here is a 1. In front of the entire absolute value sign is still just a 1. It's a negative 1, but it's still the number 1. So it stays the same shape. As long as that's 1, as long as in front of the x, in front of the absolute value is 1, it's still the same shape. And remember, that would be 1 to the right, 1 up, 2 to the right, 2 up, and same thing on this way. So we can go 1 to the right, 1 down. 2 to the right, 2 down, and you get the same exact shape, 2 to the left, 2 down, and so on. That's how you can do the same exact shape, it's just flipped down. All right, let's move on to our next. Okay, so on page 10 of your notes, we're looking at reflections now, and you can see there's 2 types of reflections. One says in the x-axis, and the other one says in the y-axis. And so you want to make sure you recognize that when it's in the x-axis, you're multiplying negative times the entire function. When it's in the y-axis, you're multiplying a negative times just the x right in there. So you want to make sure you highlight that's what that's different as. And again, these are linear ones here. I got a couple absolute value ones, but again, you want to notice this as what's going on with the negative sign. You're multiplying negative 1 times the whole function on this one. It's a vertical flip. So if we keep that vertical and horizontal words, make sure you write this down here, the whole thing. You want to write that the vertical, I'll highlight it like that, and put this underneath this one. For reflection in the x-axis, it's a vertical flip because you're flipping it over the x-axis. And so you want to multiply the entire function, the whole function, by negative 1. And so that's what we're doing here. the whole f of x function, whatever that is, you're going to put that in a parenthesis and multiply the whole thing by a negative. But this one, when it's in the y-axis, if it says y-axis, and that's what it will say. It'll say in the x-axis or in the y-axis. It won't use horizontal or vertical when it's talking about reflections. It'll use these in x-axis or in y-axis. We just need to realize that when it's in the y-axis, it's going to be a horizontal flip. You're flipping it over the y-axis, so it's going to be horizontally left or right flipping. And so if that's the case, you're going to multiply just the x by the -1. That's what's happening here. Inside the function, you're just going to multiply where the x is by a -1. So that's the only thing that's going to change. So if we look at our absolute value functions here, it makes it a little bit easier to understand, perhaps. So you have this one, our parent function right there, y equals absolute value of x. And if I multiply the entire function by a negative, now it's just negative times absolute value of x, it flips down. It flips over the absolute value flips over the x-axis. And that one you can definitely see the flip. But when you're flipping it over the y-axis, look at that, it doesn't look any different. This is the same parent function here, but this would be, let me write it. This would be both y equals absolute value of x, and it is also y equals absolute value of -x. They're both the same exact function, or same graph, I should say. They're not different. You're flipping it over the y-axis here, but when you flip it, it just flips right on top of itself. So it doesn't really change anything about the graph. In fact, we know that the absolute value of x, would be x, and the absolute value of x is x, absolute value of -x is x. They're both x, and that's why it ends up being that. So this one really doesn't have much of a change when you're actually looking at the graph, but you will multiply the inside here where the x is by a negative. All right, let's take look at a couple of those now. Okay, so on page 12, we're just continuing on now with 4 and 5. Our function on number 4 is a linear function. It's our slope is 1/2, our y-intercept is 8, so it'd be a straight line. We want to perform a reflection in the x-axis. What would the equation be if it was going to have a reflection in the x-axis? So remember, in the x-axis, when we see that right there, we know it's going to be flipping horizontally, vertically over the x-axis. So it's a vertical flip. So whenever we see the vertical word, when we understand it's going to be a vertical transformation, we know we got to do it to the entire function. Well, what do we have to do when we're doing reflections? We're going to multiply by a negative. So we got to multiply this entire function by a negative. So let's write the function down. We can see it like this. Here's our function notation, f of x. We're going to multiply this entire f of x, which is what this is. We're going to multiply that entire thing by a negative. So we're going to change it now to g of x, because that's what we have to say here. We're going to put this function in a parenthesis and multiply it by a negative, because that's what we have. 1/2 x plus 8, that's our function here. And we're going to multiply the entire thing by a negative, which means we want to distribute the negative into both of these terms. It makes the 1/2 negative, it makes the 8 negative, and so there's our answer. Here's what the equation would look like, the function would look like, with a reflection in the x-axis now. 1/2 x minus 8. All right, when we come to number 5, we see an absolute value function, because you have the absolute value signs. A lot of times we see the 4 behind the absolute value. That's okay. We could flip this around. We could put the absolute value first and then put plus 4 behind it. But what we want to pay attention to is that it's a reflection, which means we're going to multiply by -1, and it's in the x-axis. Keep messing up there. It's in the y-axis, which means we're going to be flipping it over the y-axis. That's going to be flipping horizontally, so it's a horizontal flip. So we're going to multiply the negative times the inside of this function where the x is. So here again, f of x, x is going to get multiplied by negative. This last one, the whole function got multiplied by negative when it's vertical. So now what we need to do is we need to go into our function here, and we're going to multiply this x by a negative. So that's going to get multiplied by a negative inside there, which really is only going to just change it to that right there. So that's all it is. Now what we notice here is we have x negative, and we don't usually like leaving a negative in front of some kind of function. We don't usually like leaving the function looking like this where the variable is negative. So what they're going to want you to do is they're going to first want you to factor out a -1, just like I did here, from both of these, and that would change this x to positive x and this positive 1 to -1. Changes the signs when you factor out a -1. And then they could take the absolute value of each of these. The absolute value of -1 would just be 1, and then you have the absolute value of x minus 1. So really the way they want you to see this is they want you to see, okay, 4 is still there, that doesn't get affected, but inside here really is the absolute value of -1. So I know it kind of seems a little strange. If you left it this way, it would be okay. It would just not be the proper form, I should say, that they're going to want you to write this in. So if you were to do a multiple choice test, the answer would look like this and not like this with the negative in front of x. Now let's go and look at our graph on this one. So let me pull this over here. Make it a little bigger for us. So here in the black is the parent function again. So this black one is our y equals absolute value of x. Starts at 0, 0, right 1, up 1, left 1, up 1. Remember, that's our v. We could just have those points right there, and then you just can graph it from that. So now, if this is our function here, the f of x function would be, our h and k for this one is going to be -1, positive 4. So -1, positive 4, this is going to be our f of x function right here. So the red one over here is the f of x, where your vertex is right there at, like I said, -1 for h. Your x-coordinate is always the h. And then 4, even though it's in front, usually we see it in the back, but it just happens to be in front this time. K is up front there, it's at 4. So that's where our vertex is, but it still has the same shape. You can see it's still the same shape. This function has still a 1 in front of the x. In front of the absolute value sign, there's still a 1. So that means your a number, when we talk about that, we're going to talk about an a number, that's still 1. And so you can still see it's going to go right 1, up 1, left 1, up 1, and there you have a couple points that you can just make your v. This blue one's the g of x. Same thing right there, so g of x. And for this one, our h and k from this function is going to be +1 and 4. So this is going to be +1, 4. For the vertex point, that's always your starting point. H comma k is your starting point. And then if it has the same shape, you know it's the same shape. If there's still a 1 in front of x and in front of this absolute value, then you can just do right 1, up 1, left 1, up 1, and graph it from there. If the shape changes, if there's a number in front of the x or a number in front of the absolute value sign, then you're going to want to do more of a table of values. All right, so go ahead and, you might want to pause the video and just kind of graph this there on the side. Get this one graphed out. You can graph all 3 of the functions right there. And then play the video to go on to the next part. Okay, before we go on to the next part, let's do a little quick joke of the day. Why shouldn't you tell a secret on a farm? Why shouldn't you tell a secret on a farm? Because the potatoes have eyes and the corn has ears. Potatoes have eyes. There's an eye of the potato. You may not know that. You probably know ear of corn, right? But there is an eye of the potato if you're not familiar with that. Okay, moving on to stretching and shrinking. So stretching and shrinking are our last 2. So remember, there's the translations, that's moving left or right, the h and k. There's the reflections, which is multiplying by a negative. And now we're going to see stretching and shrinking. So now we're going to see multiplying by a number, multiplying by some number. And that number could be greater than 1, or it could be between 0 and 1. So that we saw was the difference there between the stretching and the shrinking last time, was that if it's more than 1, if you're going to multiply by a number more than 1, it's going to stretch. If it's going to be less than 1, it's going to shrink. However, We were only just talking about the vertical ones on the last lesson. Now we're looking at horizontal and vertical stretching and shrinking. So again, horizontal we know, and we want to write this down over here. For the horizontal one, either underneath or next to it, right here, horizontal, again I put the same thing there, but the main part is multiply just the x only by the reciprocal of the factor. And I highlighted that, the reciprocal of the factor number. That's very key. Make sure you see that, make sure you write that down. That's really important, because we're going to talk about this factor number. Now for the vertical ones, and you can write this down for the vertical ones, it's the same thing. That's the outputs, it's the y value. You're going to do it to the whole thing. You're going to multiply the whole thing by the factor number. So you're going to have a factor number to multiply. It's going to say you're going to stretch, have a vertical stretch by the factor of this number. It'll tell you the number. Or a horizontal shrink by a factor of this number. And it'll tell you that number. So that's where you have to recognize, which one is it going to be? Is it, you got to recognize, is it horizontal or is it vertical? So that's going to tell you where to multiply. So if it is a horizontal, if it does use the word horizontal, okay, so for when it says horizontal stretching or shrinking, you're going to multiply the x inside the function right there by whatever number it says to multiply by. And actually not by that whatever number it says, sorry, by the reciprocal of that number. So if it says horizontal stretch by a factor of 2, you need to multiply by the reciprocal of 2, which is 1/2. Or if it says a horizontal shrink by a factor of 1/3, then you got to multiply by 3, the reciprocal of that. So that's where it gets a little confusing there, that you have to make sure if it does say the word horizontal, you're going to be taking the reciprocal of the number that it says to multiply by and doing it on the inside where the x is. Now when it is vertical, it's a little easier, because vertical you're going to do it to the outside of the function. You can see right there. You're multiplying the a, the factor number, by the whole entire thing, by the whole thing, the whole entire function. Whatever that function is, you're going to multiply the whole thing, distribute that a number into the function. Now this one, you do not do the reciprocal. Whatever the factor number says, if it says vertical stretch by a factor of 2, you multiply by 2. If it says vertical shrink by a factor of 1/3, you multiply by 1/3. So for this one, you multiply by exactly what it says. But on horizontal, you multiply by the reciprocal of the number it says. Okay? Now these do show, I don't really want you to pay attention to the linear ones. It's really hard to see stretching and shrinking of a line. But that's why I put this here for the graph of our V-shaped functions, absolute values, so you can kind of see the different ones. There's 3 different functions on here. In fact, the parent function is not even on here. But you can kind of see the different shapes of them. This one's a little narrower. This black one's like the widest one here. And so you have, stretching and shrinking. The red one would definitely be more of a stretch from the black one. If you say this blue one right here is like the middle one, the red one's still a stretch from the blue one. The black one looks like it's a shrink from the blue one, because it's getting a little wider and a little flatter. So remember, that's what happens to the stretching, is that it gets narrower or thinner, but the shrinking gets wider, or flattens out. That's what happens there. All right, let's go on and try a couple of these. Okay, so as we now go to page 12, go back to page 12 where we're looking at 6 through 9. You can see the transformations are talking about the shrinks and the stretching. So we're going to look at the first one. It gives us a linear equation, right? Because it's just got negative 5x. Nothing else is happening to x, so it's like a slope is negative 5. There is no y-intercept, which means our y-intercept would be at 0. So that would be easy to graph. Just plot 0, 0, and then your slope would go, basically rise would be going down 5 and run 1. You just put this over 1. Now if we want to try to shrink this, vertical shrink by a factor of 1/5. So here's what I was talking about. We gotta recognize, okay, it says vertical 1, so that means we gotta do it to the outside of the function, which means we really don't have to worry about this word so much of the shrink. The shrink is because the factor is less than 1. It's between 0 and 1. That's why they use the shrink word. But really you want to recognize it's vertical, so it's going to happen to the whole function, and we're multiplying by what it says. So vertical, you multiply by 1/5. If it says factor of 1/5, we're going to multiply by that with the vertical word. So we're going to multiply 1/5 times the entire function. Our entire function is just the negative 5x. So we're going to write this down. I'm going to name it g now as well. So I'm going to name it g of x is equal to negative 5x. I'm going to put it in parentheses here and multiply by 1/5, which means I'm going to cross cancel my 5's. So when I cross cancel 5's, this is now just 1 outside here, and now I have a negative x on the inside. 1 times negative x will just be negative x. So the g of x function with a vertical shrink by a factor of 1/5 is just x, or g of x equals negative x. That's it. For number 7, there's our absolute value function. We want to do a vertical stretch by a factor of 4. So again, it says vertical, which means we're going to just keep the number 4 the way it is and multiply the entire function here by 4. So I'm going to say, okay, there's f of x is going to get multiplied by 4. We can see that as the notation. 4 is timesing the entire function. This entire function is this right here. So I'm going to write that down, but I'm going to name it g. All right, g of x equals, here's this function. I'm going to put this whole entire function in a parenthesis. So I'm going to put that in a parenthesis and multiply by 4. So 4 is now on the outside. I'm going to multiply this whole function by 4. So I'm going to distribute this in. But now here's where you got to be careful. You can't distribute it into the absolute value symbols. You can only say 4 times the absolute value of x plus 3. You're not going to put 4 in for x and 4 in for 3. You're not multiplying both of those. There's really just 2 things you can multiply. The absolute value, so just 4 is going to be in front of the absolute value, and then 4 can multiply 2. So that's where you got to be very careful. Don't distribute 4 into x and 4 into 3 separately, because it can't go into absolute value symbols. It does have to just remain intact. The only way you can get into there is if you're going to substitute something in for x. So that's now going to just look like this. 4 is on the outside of the absolute values. Notice it didn't change. X plus 3 is still the same. But now 4 times 2, it's a plus 8 at the end. And so there's our new function for g of x. 8 is a horizontal stretch by a factor of 6. So again, when it says horizontal, that means we're going to do it to the inside of the function where x is. So it's got to be inside. We're going to multiply in here where the x is. And because it's horizontal, here's the part that can get confusing. You have to multiply by the reciprocal of the number. So the reciprocal of 6 is 1/6. So this is what we're doing. The x inside the function is going to get multiplied by 1/6. Now that tells you what you can substitute in for the x in this function. So now as we write down the g of x function, it's going to be 3 times 1/6 x, and then minus 9. And so you can see as we do that, we can cross cancel 3 and 6. 3 becomes a 1, 6 becomes 2, and so that now leaves us with basically a 1 outside here, 1/2 x now, times 1 is still 1/2 x, so this whole thing becomes 1/2 x minus 9, and that's our function after we do the horizontal stretch by a factor of 6. Now the reason why they use a stretch word is because the factor number here is bigger than 1, so that's always relating to that. So if your factor number is more than 1, you're going to use the word stretch. If your factor number, like up here, was less than 1, you're going to use the word shrink. So that doesn't matter whether it's vertical or horizontal. That's always just the same. Now number 9, when we come to this one, horizontal. So again, it's the same thing. It's going to go on the inside. But again, the factor is 1/4 here, which means we want to change that to the reciprocal of 4. So if I flip it, that's 4 over 1, which is the same as 4. So 4 is going to get multiplied by x on the inside, as you can see. So here's f of x. We're going to multiply x on the inside by 4. That tells us what now we're going to replace the x with in here with a 4x. So as we put that in now, do it up here. Call it g of x equals the negative 8 times x, but instead of x, we're going to put in times 4x. And then still we have a minus 4 in the back. So now we just need to multiply 8 times 4x inside here. So that's why we can change what's inside here when it's a horizontal one. 8 times 4 is 32. So our final equation here. or function is going to be g of x equals a negative with the absolute value of 32x minus 4. Now I did want to show you a couple graphs here. I think maybe I'll just do the one graph. Let's just do number 7. I think that might be good. Maybe I will do 8 too, just because it does have that one, or 9 I should say. Let's take a look at this number 7 real quick and just kind of see what that looks like. There's our black one's our parent function, where it's just the absolute value of x. The red one, as you can see on this one it has an h and a k, which is going to be our function, our f of x function here. It's negative 3 for h, positive 2. So this is negative 3, positive 2. It's still the same shape, as you can see. So that one right here now is still the same shape as the parent function. So we could still graph this one, go to the right 1, go up 1, go to the right 2, go up 2, and the same thing this way. Has the same exact shape. But when we take a look at now our g of x function after we did the vertical stretch, now we have a number in front here, so it did, notice how it stretched it. It's now thinner than these ones. So it made it a thinner graph, a narrower graph. So it has a new vertex point as well, which would be negative 3, positive 8. So if we go negative 3 and up to 8, there's the vertex. And it also has a new shape. So to graph this shape, you can't go off of the pattern anymore. You can't go right 1, up 1 anymore. You're going to have to go right 1, and that's the number you want to put in for x. So for this one, if we go to this way 1, it's negative 2. You could do negative 2 in for x and plug that in and get your output. That would tell you where to go up. You can go to the other side one direction this way. It should go up exactly the same amount. Okay, so that's what you want to be doing when you do now have a stretch or a shrink graph. When you have a number in front of the absolute value symbols, or you have a number in front of the x in the absolute value symbol, that's the same thing as here. So let's take a look at maybe this one real quick. So this one's got your parent function up here, and then the red one is the original function here. It already had a number in front of x, which changed it. It actually, you can see how it got narrower than this one. So it did have this stretch here, because that 8 is bigger than 1, right? It's more than 1, so it's going to stretch it. And also when we get it even at 32, it's going to stretch it even more. So the blue one actually is our g of x function. So it stretched it even more when it was 32. So you can see how that works with the stretching. Now I know it did say a horizontal shrink. If it's a horizontal shrink, it's really going to be always the opposite, because remember we're taking the reciprocal of this. We're doing the reciprocal of the 1/4, so it's going to look more like a stretch. Horizontal shrinks look more like stretches, look more like vertical stretches, I should say. Okay, so here's our last couple problems. Number 10, it says consider the function, and there's our parent function for the absolute value. And it wants us to write a function g, kind of like what we've been doing. This graph represents a reflection in the x-axis. We've already done that, but now it says followed by. So the followed by means we're going to have more than one of these transformations to do on the same, on the same function. So after we do a reflection, we're now going to also do a horizontal stretch by a factor of 3, and a third part, a translation 5 units down of the graph of that f graph up here. So we just start doing one at a time. That's all you do here. So let's just start with the reflection in the x-axis. So remember, x-axis, that would be a vertical flip. Whenever you see reflection, you're multiplying by a negative. Where do you multiply that, though, when it's in the x-axis? That's to the outside of the function or the entire function. So we're going to multiply the outside of this by a negative, so now it will look like this. We'll call it g of x equals negative times the absolute value of x. If it was in the y-axis, the negative sign would just be inside with x instead of outside. So now we do the next part to this one now. So from here, we're now going to do a horizontal stretch by a factor of 3. Now if it's horizontal, remember what we have to do with the 3 is take the reciprocal of that number. So really it's 1/3. So we're going to multiply by 1/3 where? Well, horizontal is always on the inside, so it's going to have to go on the inside. So x is going to get multiplied by a 1/3 now. So now it'll look like this. Our g of x, I drew an arrow here to show here's our next part. So we're still calling it g of x. Still have my negative on the outside, but now inside here, 1/3 is multiplying by x. That's after doing the horizontal stretch by the factor of 3. And then the last part is translation 5 units down. Now remember, down would be vertical, which means you're going to, that's a negative from 1. It's the negative direction, so it's a -5, which means you're going to subtract 5 from this entire function, which really means you're just going to put -5 in the back of this function. So, another arrow here. Here's our final function. G of x equals the negative sign from the first one, the absolute value of 1/3 x from that second one, and here's the -5 from that third one. And that's it. Number 11 just says which of the transformations in this section will not, carefully there, will not change the y-intercept. So it will not change the y-intercept of the graph of this. Now we might want to look at the graph of this, absolute value of x plus 3. So it's an absolute value function. We can go ahead and draw a coordinate plane down here, kind of like that, a little x-axis, y-axis. Where would be the vertex, the starting point of this graph? It's always the h and k. Well, if it's just the absolute value of x there, it means there is no h, which means h would be 0 in this case, and k would be 3, so 0, 3 would be our starting point right here. So 0, 3 right on the y-axis. So x is 0, y is 3 is right there, and it does have the same shape as the parent function, which we know the parent function will go right 1 up 1 and also left 1 up 1. So we can put those 2 points down and then just draw the V shape. So there's our V-shaped function. So it's maybe helpful for us to see this now to be able to answer this question. Which of the transformations, now there's the translation, right? Either there's horizontal or vertical translations. There's reflections in x-axis or y-axis. So you have a kind of 2 of each. There's the stretching, horizontal or vertical. There's the shrinking, horizontal or vertical. Remember, there's kind of 2 of each of them. There's a horizontal or vertical of each transformation. So which one will not change the y-intercept, which would be where this vertex point is? So if we translate it up or down, left or right, that's definitely going to change that. So it can't be any translations. If we do a reflection in the x-axis, if I flip it over the x-axis, that's going to change it to down here, so that couldn't be that. But if we do reflect it in the y-axis, remember how we saw that one? It didn't change the graph at all. So we could have a reflection in the y-axis, and that would not change this point right here. It would stay the same. There's one other thing we could do if we do talk about stretching and shrinking. If I do a vertical stretch or shrink, either way, that means I need to multiply the entire function by some number, which means I'm going to be multiplying this number 3 by whatever that number is. So vertical stretch or shrink will not work here because that will change this 3. The 3 is really right here, the one we don't want to change. So what could change is if I multiply by horizontal inside here with x. If I just multiply the x, that'll leave the 3 alone. So the other one could be a horizontal stretch or shrink. So those are the transformations. There's kind of like 3 of them: reflection in the y-axis, horizontal stretch, and horizontal shrink. That would not change this 3. All right. Okay, yeah, that's going to conclude our lesson for 1.2. And so you want to go on to the assignment for this lesson, and I'll see you on the next lesson. All right, have a good day.